thanks everyone for I don't know, tuning in or sitting down and listening or whatever. These webinars are kind of cool. You can participate at the end here. We'll have a question session, but I'm not sure how to introduce them really well. But this one's a good one so far. This is the fourth talk in our series of 5 webinars on monitoring drought, sort of from space and on the ground. Brian is coming to us from the NIDIS, which is sort of in charge of making the whole drought monitor that we see. He's at the Drought Mitigation Center at the University of Nebraska-Lincoln. He's been there for a while. He's sort of kind of tasked with working like this in the most applied sense, I think. And today we're going to be treated with really kind of how they make the whole drought monitor. So the title of his talk is going to be Making the United States Drought Monitor. With that, I think we should just get into it. I'm looking forward to it. And when you have questions, you can type them all in at the end. We'll try to limit that to the end and not during the middle. So unless Brian wants to stop sometime along the way and take questions, he's welcome to. But it's really free form. So Brian, with that, I'll let you go to it.
All right. I appreciate the introduction. And yes, a little bit about myself. Brian Fuchs. I'm a climatologist here at the National Drought Mitigation Center, and we are at the University of Nebraska in Lincoln. And what I'm going to speak about today is the work that I'm closely associated with, which is the making of the U.S. Drought Monitor product, which I'm sure many people, or probably most people on this call, have at least seen or know a little bit about. But what I want to do today is just give a little bit more of a thorough introduction of what the Drought Monitor is, and also spending some time talking about some of the specific tools that we are using and kind of how the Drought Monitor is flexible enough to change as we do have other tools and data sets made available to us. So my preference is I'll go through the slides. I have about 30 slides to go through, and then I'll definitely leave time for questions at the end, and then we can answer them all then. So when we start talking about drought assessment and drought monitoring, historically there's been various methods of doing this. Typically you can look at a single index or an indicator, individual parameters such as snowfall, precipitation, stream flow, reservoir levels, etc. Or if you want to become more complex, you start looking at 1 or 2 of these indices or indicators to get a better idea of what the drought story is or what the drought situation is in your region. And finally, the one that I'm going to talk about today is this composite or hybrid approach, meaning that instead of just looking at 1 or 2 indicators, we're looking at as much information or all the data that's out there that's possible to put together this assessment of drought. And with that, I'm going to discuss the techniques and ways that we work to bring this all together with the work associated with the U.S. Drought Monitor. So in the past, realistically, the Palmer Drought Index was the first real drought index that was developed in the 60s. And when Wayne Palmer was tasked at developing this index, it was because USDA was very interested in what drought was meaning in the agricultural or grain-producing regions of the country. So for a long time, the Palmer Drought Index was the only one around. Has been used a lot. It's been vetted in both research and in the literature quite a bit. But what we have found out is over time the Palmer works great in some areas. It doesn't work as well in other areas. And there's also some interesting parts to the Palmer that make it not work as well in some areas. So this is looking at the summer of 1999. And what we can see is along the Mideast part of the U.S., there was a pretty significant drought going on, and this was the tool that was made available to analyze that drought. So as we move forward in the summer of 1999, the idea was, well, we can do a better job at identifying these drought areas than just looking at a drought index like the Palmer. And so the drought monitor work was started. Mark Svoboda here from the National Drought Mitigation Center and Doug LeCompte, who has since retired from the Climate Prediction Center, They had sat down, and Mark had presented a talk at a meeting, and Doug liked the concept and the idea, so they got together in the summer of '99 and put together this prototype of what would become the U.S. Drought Monitor. As you can see, it looks very much different than the maps produced today. A lot of differences in these early maps, but it was really that first attempt at looking at a lot of different data sets and putting together a single product identifying drought. So as we move forward from that, we do get to what the inputs were within the first U.S. Drought Monitor maps. And realistically, for the drought indicators, the indices, we had the Standardized Precipitation Index and the Palmer. We had some rudimentary soil moisture numbers. Stream flow was looked at. There was the NDVI products from remotely sensed satellite products. We had a handful of climatologists around the country who were interested in this, and they were contributing. And then out in the West, we knew that we had the snow information. And these were the products that were initially available when we started the Drought Monitor work back in 1999. And just another side point on these is many of these indicators, if you look at the top two images on this slide with the SPI and the Palmer, a lot of these were climate division based or very coarse in scale, and that really related to how good or how badly we could show drought conditions on the map. Just because of the coarseness of the data, it was very hard to show that really close, refined delineation between the drought areas that we were looking at. So as we move forward, we look at what we have going for us here today. And one of the U.S. Drought Monitor authors, when he first came on board as an author, this was Dave Simrall out at the Western Regional Climate Center. He wanted to put his brain around exactly what we're looking at. And so he took into account and looked at all the different notes and all the different data that we're looking at. And he put together this mind map diagram showing everything that was going into the U.S. Drought Monitor product at the time. And when you look at it zoomed in, you can see that there is a lot going into it. It isn't just a handful of indicators, but it's different time scales, it's different types of data from different sources, both federal and state level. And when we start looking at these even closer, we can see that as the U.S. Drought Monitor author starts making these decisions, there is a lot that goes into it. Some of these indicators are tied together very closely, some of them are not, but there is a lot that goes into it, this decision-making process. And so just even from the beginnings back in 1999 to where we are today, a lot has been done to really push the threshold of the data and the types of information we're looking at, and also how we're analyzing it. And so that brings us to the map. And so this is this week's U.S. Drought Monitor map. It is a weekly map, comes out every Thursday morning. Over the 15-plus years that the Drought Monitor has been considered operational, we have not missed a release, so it is something that's regular, and the stakeholders and the decision makers that use this product, they really rely on that regularity of having this at the same time, same place every week. On the map, you can see that we do have labels of S and L, and in some instances a combination of S and L. So the S designates areas where we think that the dryness and the drought signal is most closely associated with a shorter term time frame, 6 months or less. The L's are designating areas where the long-term impacts are the predominant features of the drought, and those are 6 months or more. And as you can see out in parts of the western U.S. and down in the panhandle of Florida, there are some areas that it's a combination of both, that it's both short and long-term dryness that are making up the drought signal for these regions. So as we move forward, just some background here. Again, since 1999, the Drought Monitor has been around, and this is not something that is just the National Drought Mitigation Center's product, but it is done in conjunction with NOAA, and the partners within NOAA are the Climate Prediction Center, NCDC, or now NCEI, and the Western Regional Climate Center. The USDA is part of this, as well as the NDMC. And so we've produced this weekly composite each week since 1999. Like I mentioned earlier, the Western Regional Climate Center came on board in 2008. We really wanted to have a Western author because we realized even from the beginning that drought in the Western U.S. is quite unique and quite different than when we start looking at drought in other parts of the country. Currently, we have 11 authors in all, and we try to incorporate different types of information and products from all entities and levels of government, from state climate offices to regional climate centers to federal and state agencies. And we also have some eyes and ears on the ground with about 350 experts that chime in each week during the making of the U.S. Drought Monitor, and I'll touch on that a little bit more as we go along. So when we have this authoring group, you can see this is the home base of where these authors are. So at the National Drought Mitigation Center, we have 2 authors and then the one in the west, but pretty much everyone else is along the East Coast, and even 6 of the 11 are within the federal agencies in Washington, D.C. To be an author, you must work at a regional or national center, a government or academia research center. And again, there's 11 authors, and we're all volunteers. This isn't something that you get hired on to do, but we do this in accordance to the directives associated with the Drought Monitor, but we also do this while doing our regular job, so to speak. So when we start looking at the information to put together the weekly assessment, we are looking at current conditions. It's the U.S. Drought Monitor is not an index. It's not something that we plug a bunch of information into formulas and we get a map out. It's not a model. We're not trying to look at conditions and make them appear to any type of modeled information. It's not a forecast or a drought declaration. We're not producing this to look forward as a forecast would, and realistically for drought declarations, only the governor of each state can declare if that state is in a drought or not. So we're really looking at just showing where drought conditions are and the intensity of drought. Again, we identify the impacts with short and long-term labels on the map. We incorporate these local experts into the information that we're analyzing, and we try to be as objective as possible. And the methodology for being objective is looking at these percentile rankings, which I'll touch on in one of the next slides. The convergence of evidence approach. It doesn't happen too often that when you start looking at all the different data inputs and data streams that are being considered in the weekly product, that they all line up nicely telling the same story as far as where drought is and what the intensity level is. So what we do is we kind of treat it like you would a case being discussed or argued in the court of law. We look at this convergence of evidence. When we start taking into account all the information presented in front of us, what is the story that evidence and information is converging to? And that's what we end up doing as far as showing the drought intensity levels on the map. So within this convergence of evidence, there's many types of information and indicators that we're looking at. And we need to determine, is this information all telling the same story? And because that's telling us how accurate or inaccurate we are on the map. We need to look at all the data, everything that's available, but not one piece of the data is going to tell the entire story. So even though we look at 40 to 50 indicators in putting the map together each week, we don't put all our eggs in one basket, so to speak, and just looking at a single indicator and saying, oh, that's what the map should follow, that's what it looks like. But we look at all of the information. Well, when doing so, there are different parameters that are being discovered and investigated in doing this weekly work, and these are the parameters that we need to identify the drought signal. So those are going to be both climatological and hydrological, meaning we're going to be looking at what the current conditions are compared to what where they have been historically for this time, or date, or for the exact time that the map is being done. And the key to all this is looking at impacts as well. When you start considering drought impacts, they are validating the map, or they're ground truthing the map in a way that if we are not seeing impacts on the ground, are you really having a drought? And that's a key question that the authors are always faced with, and what we try to consider, that the conditions need to be such that if you are showing drought on the map, there has to be some kind of impact associated with that. And that's where those experts on the ground come in, and they provide this information, or ground truthing of exactly what the impacts they are seeing in their area. And so within the convergence of evidence approach, I mentioned the ranking percentiles. And early on with the discussions of the drought monitor, we realized that not all the data sets we're going to be looking at are going to have the same period of record. Some precipitation, you may have 100 years. Snowpack, you may have 20 years. Streamflow data, you may have 50 years, and so on and so forth. That not all of these are going to have the same period of record. But we needed a methodology of how we are going to compare all these different types of data, various periods of record, but we need to look at them all at the same time, and we need to look at them in a way that they make sense. And so the idea is, with ranking percentiles, you can take those pieces of data and you can rank them from driest reading to wettest reading, or lowest reading to highest reading, for whatever period of record that you have, and you can look at where your current data falls into that historical perspective. And so, for example, if I'm looking at precipitation data, and it's showing me that I'm currently the 11th driest over the last 6 months for the state of Texas, for example. Well, that's telling me that for precipitation, I'm falling into almost the D2 intensity level, but realistically it's still D1. That happens 20% of the time. And you can also get a return period on this. So if I'm looking at D4, which is the second percentile, that's telling me I'm getting conditions like this about once every 50 years or so. D3 at the 5th percentile about once every 20 years, D2 about once every 10, D1 about once every 5, and abnormally dry conditions, which we don't consider drought, about once every 3 years or so. So it does give us an opportunity to take all different types of data and look at them side by side and end up with some kind of assessment of drought at the end when all these pieces of information and data are considered. And again, when we start talking about drought, or even from our own perspectives on drought, typically what we remember is the last drought event, or even the current one, and how it relates to the last one. A lot of times we don't have the personal knowledge or the institutional knowledge to say exactly how the current situation ranks historically. And so by saying, yeah, that's really dry, or I don't remember it being this dry, we have to be D4, that doesn't work, because realistically it's a perspective, and it really doesn't have a scientific backing behind it. But if I say, yes, it's really dry, I don't remember it being this dry, and we start looking, and then I follow up that statement by saying, this is the driest 6 months we've ever seen. It's the second driest reading we've ever had on the river that flows through this region. We can start piecing these parcels of data together to get the idea that, okay, this dryness we are seeing does have a historical perspective that we can relate it to. And when we start looking at the different intensity levels, we have, again, the abnormally dry, which we use as an area, is starting to go into drought, but hasn't quite reached that drought level, or it's coming out of a drought, and we've had some recovery, but we still know that there's lingering dryness. That's where we use the abnormally dry. But for the 4 intensity levels, we start looking at some of the possible impacts. And early on, this table was developed, and a lot of these impacts are quite broad in nature. And what we've come to realize, that drought does mean different things to different parts of the country, and not all these impacts are going to mean the same thing depending on where you're at, or the time of the year, or even crucial periods that are associated with agriculture or cattle production. And so what we are doing now is we are actually in the process of taking this table and refining it on more of a state or even a county county level basis, and just giving a better picture of what drought means to different parts of the country. But this is where we started, and again, without impacts, it's really hard to identify the exact intensity of the drought level that you have. And I talked about how important it was for this on-the-ground assessment of drought and this validation by these local experts. And we have a Drought Monitor list server that's set up, and currently there's a little over 360 people on that list, and this shows the distribution of where those people are. Not too surprisingly, some of the states in red and yellow have seen quite a bit of drought in the last several years. And in some areas like Puerto Rico, we've had some drought here recently that we used to have one person, and now we have 3 people that are participating. But what happens is, in this process of making a map each week, these local experts that we call them, we communicate through this email list, and they see the drafts of the map that are being done, and they comment back that, this area is not as dry as some of the areas to the south, and it should not be in D3 this week. It should still stay D2, and this is the data that we can show to support this. Or we're not seeing the same types of losses in this area as we are further to the other side of the state, and until we see those same types of impacts or losses, we want to hold off on that expansion because it's just not matching up with what the indicators are showing. And that's a great point that I want to bring up too, is sometimes there is a disconnect between the data that we are looking at and the conditions on the ground. And these 360 plus people do a great job of providing that information to us, hopefully shedding some light on why there is a disconnect, or if there's more or better information coming from another source that we need to consider. So part of this process, too, is we like to listen to the stakeholders. From the very beginning of the U.S. Drought Monitor, there has been an annual forum for feedback. And what these forums do is they allow stakeholders to come in, make suggestions about the Drought Monitor, what they like, what they don't like, what they'd like to see, what they think could be done better, maybe introducing new types of data, new types of analysis to us. And so that all gets discussed on a yearly basis. And so as you do look at the Drought Monitor maps over time, you do see that there has been some substantial changes just in the visual aspects of the map and how the map is being done. There's various webinars and telecons that take place during the production of the map each week. And as an author, I like to sit in on these as many of them as I can, as often as I can, because these are the local experts, and they're talking about their state or they're talking about their region. And by listening to those experts and hearing their assessment, I can cover a large area of the country in a short period of time without having to dig into the information myself. So it helps speed up the process for me, and it helps me allocate more time to areas of the country that I need to look at that maybe are not as coordinated. The state climatologists are a big player in the Drought Monitor because they not only, many of them are at the land-grant universities within their states, but many of them have the connections to the extension agents in the states, and they know the pulse of what drought means in their state and can report back quickly and accurately on these conditions. We also have set up arrangements with some tribal people to be involved. And again, with some of the tribal lands, they typically are very underrepresented as far as the instrumentation that we have. So unless we're looking at something that's remotely sensed that can pick up those tribal lands, sometimes they are in areas that are very poorly represented with on-the-ground data. So it is good to have those ties into some of the tribes. The COCO-ROS network has been huge as far as not only filling in areas where rainfall does and does not take place, but the COCO-ROS observers have also been employed in essence by collecting and reporting drought impacts. So some of these observers, when they go out and they do their daily report of precipitation, they also are at the same time reporting any types of drought-related impacts that they are observing in their area. We've also worked with the National Integrated Drought Information System, which is the NIDIS acronym. And this, they have helped with several pilots on these drought early warning systems throughout the country, and we've been involved with them, again, trying to spin up more of a coordinated effort in reporting drought conditions to the Drought Monitor authors. And I mentioned the various states that have their weekly drought task force calls that we hear from and participate in some of these as well, and they're very useful as far as bringing that local information, that very highly detailed information in front of the Drought Monitor author. So when we start looking at the data, again, I mentioned that we are looking at anything that we can get our hands on, so to speak. Some of the key indicators over time have been, again, the drought indices such as the Palmer and the Standardized Precipitation Drought Index, but also the KBDI, some of the modeled soil moisture products, looking at some of the stream flow products, and also precipitation anomalies. During the growing season, there's a whole suite of indicators that we look at that are very much related to crop production or the agricultural production across the country. And like I said, in the West, some things are very unique compared to the other parts of the country, so we start looking at SWASEs on particular river basins. We look at the reservoir levels, snowpack, snow water equivalent, and the stream flows are very important in the Western depiction of drought. And again, over time, as our group of local experts has grown, we started off with about 20 hand-picked experts that contributed each week to the making of the map, and that has grown to the 360 that we currently have. What they have also done is they started developing products just for their state or just for their region that are very helpful. Sometimes they're at a higher resolution than what we have on a national level for some of these data. And they're very useful as far as helping the Drought Monitor author depict what the drought assessment is going to look like that week. And we can see some of them like the radar-based precipitation product out of Texas, or the data from the Oklahoma Mesonet or the Nebraska Mesonet, the Midwest Soil Moisture Model from the Midwest Regional Climate Center, and so on. So a lot of these groups have developed data specifically to feed into the weekly work that we're doing with the Drought Monitor, which again has been very helpful. And again, we communicate all this through the list server that we have. So back in about 2008, several of the authors started running some data scripts to bring in these data to look at right in our GIS projects when we're drawing the map. So I guess a little background on that alone is I mentioned that the Drought Monitor is not a model and it's not a formula, but each week we start with the previous week's map, and we have that in ArcGIS, and we take and move those lines manually, node by node in GIS, in relation to the data that we're looking at. So we may make a lot of changes one week, we may not make too many at all, especially in a week-to-week product. We know that drought typically does not change that quickly outside of flooding rains or tropical rains really impacting an area. So what these authors started doing is developing these Python scripts which started pulling in and interpolating these data that we were typically looking at each week, but they were allowing us to bring that data right into our GIS products and show it as an overlay along with the Drought Monitor contours. So we were no longer having to just eyeball it from a static map, but we were actually able to bring that into our project and draw the map right up to where those data points were showing the transitional zones or the delineations between wetter and drier regions, which was a big step forward for us. So what's going to follow is just an example of some of these data that we started using. And so on this frame here, the upper two national maps are showing stream flow and precipitation data with the Drought Monitor contour shown as well. So this is very good as far as showing areas where, hey, we know they picked up a lot of rain. It was in an area that we were in drought. We need to dig in and see if some of those areas received enough precipitation to show improvement. Or it could also show you vice versa. Okay, this area has been in drought. They didn't get any rain this last week. We know that we need to start looking for further degradation in that region. And same with the stream flow. We started looking at some of the NLDAS products, the gridded soil moisture products. And also from the regional climate centers, the Applied Climate Information System, or ACIS, the maps and products associated with their data became very helpful as far as exactly knowing where these data were coming in. More recently, we have seen Martha Anderson's group developing the ESI, or Evaporative Stress Index, again looking at evaporation or moisture loss during particular periods of time, and even the change maps associated with it, so we can see areas that based on evaporative losses we could dig in to see, again, are these causing drought-related stress. On the lower level, looking at the NDVI, and also actually from our shop, the VegDry tool, which is looking at drought response, or how vegetation responds to drought, and this coordinated tool of both satellite and surface-based observations. And again, we start digging into some of this stuff at a very fine resolution. And again, the real limit that we have right now is not all of our data sets can be shown at such a high resolution, and it leaves us, some of those data sets leave us with the opportunity to interpolate between points. But the newer tools are actually filling in more of those gaps. So when we get into our projects, we have this data in the background, we can zoom in, and we can really start seeing the changes that we need to be made for that week. And so during this analysis, this is an actual screenshot of what my project looked like when I was doing a map one week. And so this is the dots in the background are the SPI values for this point in time, and I think they were 6-month SPI values out in the west, and we can see the D2 and D3 contours already on the map. And so when I'm starting to look for changes, I can see, should I be pulling in these data? Should I be pulling in the drought monitor layer to capture more of these data that are showing extreme drought, for example, or D3 on the map? And we can also bring in, this is the NLDAS soil moisture model, and this is looking at the full moisture, or the full moisture profile, and then breaking that data into the percentiles again. And we can start looking at this along with the other data. So what it does is it allows me as an author within GIS to bring in these data. I can click them on and off quite easily with my menu bar on the left, and then also have my current drought monitor depiction shown, so I can get an idea, yep, I need to expand the intensity into this area, or no, I can look at the improvements or pull back some of the drought in an area, and these tools are allowing us to do that at a much finer resolution than we were able to do in the beginning with climate division-based data. The USDA has started using the drought monitor as well to identify areas of the country that are being impacted by drought in these grain-growing regions or crop-producing regions. So this is just an example from the summer of 2012 into the fall of 2012, when we had the extensive drought over the grain-producing regions of the country. So at that point in time, it was showing that 84% of the corn-growing regions in the country were suffering from drought, and USDA can use this information then on their analysis of what the yields will be like, and they do this for wheat, soybeans, pasture lands, cattle areas as well. And so over time, early on, the drought monitor did not have a long enough track record for people to really use it in decision makings, but over time it's been vetted quite a bit, been referenced in the literature quite a bit, and so policies started to follow. And we can see that in the new Farm Bill, the 2008 and 2014 Farm Bill, there's specific language and programs associated with the drought monitor in there. The IRS has used it for livestock deferral programs. The U.S. Department of Ag has used it for secretarial fast-track drought designations based on levels on the drought monitor. The Weather Service has started issuing drought information statements based on being in D2 or worse on the drought monitor. It's being used for water quality monitoring by the EPA, for public health issues, especially with diseases that are associated with certain insects and that. The Center for Disease Prevention and Control is using it. And many states are using the drought monitor within their state drought task force and state drought plans as a triggering mechanism. For example, if an area hits D2 in a state drought plan, it says that that area that is now impacted by D2, they need to start voluntary water restrictions. And so that's just an example of how the drought monitor has started to be used more so in policy. So just to finish up here quickly, the drought monitor, again, I showed how it started very simple, but it has built up over time. It's a lot of collaboration, not only collaboration between federal agencies, but different agencies at the state level as well. It's about this process as well. It's these groups working together for the good of a common goal, sharing the data, sharing the product, sharing the credit associated with it. The convergence of evidence is important because if you don't have the scientific data to back up a change on the map, then you probably shouldn't be doing it. And that's, you know, at the end of the day, when I'm doing the map and my name is on there, if anyone calls me up, I need to be able to justify why the map looks the way it does, or any change I made on that map. I need to be able to support it scientifically. We've been very transparent through this whole process, and we've gained a lot of trust with people through just explaining the process, having them become involved in it, and involving the local experts has been key. Again, when you build these partnerships, there is some ownership and validation that is being considered by these people. They're taking a lot of time out of their week to participate, but they can also see that they do have a little bit of ownership to it. And the value-added knowledge that we tap into with this local expertise is just something that can't be replicated. It's those personal connections, knowing that if I need to have more information coming from a state, I have a name I can call or a group I can call, and they're going to be ready to help me out. Collecting these impacts is crucial, and it's something that needs to be done more. We need to document more of these drought-related impacts so as we go into the next drought, we can recall, hey, this is what we saw last time when we were entering a D2 or D3 drought, and this is what happened on the ground. We need to be flexible in this process as well, because as new tools, as new information become available, we need to be able to incorporate that into our weekly dissemination of this information. Some of the derived products are great, and we need to keep them within the making of the drought monitor, but we also need to identify and acknowledge those that are making some of these data sets because they are crucial. We have to stay transparent in this whole process. It can't be done behind curtains, but everyone needs to know up front, this is how it's done, this is what we're working towards, and inviting people to become part of the process, become part of the listserv. If you can contribute or if you're developing data that can feed into the process, we'd love to hear from you. So some of the keys that I like to mention when putting together the map at the bottom, again, this open data sharing, the local experts, the creating of the map, being flexible, listening, and again, you have 11 different people with 11 different perspectives all putting this information together into a weekly map. So some of the critical observations to end with here, no single indicator or index is used solely in determining appropriate actions. Instead, there's different thresholds from different combinations of inputs. It's the best approach. Again, this composite approach, instead of just looking at one or two, we're trying to look at everything. Decision-making or triggers based on these values are supported favorably, and they're better understood by people when they can see why a decision is being made or how come a certain action plan was started. Again, based on those triggers that you can back up scientifically, it does make more sense to people. So some of the next steps associated with the drought monitor work, again, continue this interactions with these local task force, the the local experts on the ground, getting more people involved in the process, having that number grow from 360 to maybe 400 in the next couple of years. New state and basin interactions through the NIDIS work and some of the drought early warning systems. There's a NIDIS project that was started in the Missouri Basin just a few years ago, and one that is getting spun up now in the Midwest, as well as others. Again, we want to bring in more of this data via GIS. And so when we work with people that are trying to supply us with information or data, we talk to them about how vital it is for them to do this in GIS. Bringing in some of these gridded data sets or interpolated products that makes it available for us to use right in our map making of the weekly product. So with that, I'll have you start with any questions. My contact information is here on this page, and if we don't cover something today, or if you want to talk offline about anything I presented today, or if you have some ideas you'd like to share, feel free to contact me. I'd love to hear from you. So thank you.
All right, thank you very much, Brian, for your presentation. So at this time, we'll go ahead and take question and answers. So if anyone has a question, feel free to type it into the chat box. Okay, looks like we've got some typing happening here. Hey, and here's a question from Steve Burgess. You include reservoir storage, but did you consider how the reservoirs are operated?
That's a great question, Steve, and most definitely when, and even with some of the river and stream flow data, there are operating procedures or operating curves associated with them, and that is considered, and again, that's where the local experts really can chime in and help us to better understand that. Many times we have gotten feedback that, this reservoir moved their water sooner than they typically did, or the changes in stream flow is something that we always see this time of year because of the operation or guidance curves that they go by. So most definitely that is considered.
Any other questions for Brian? Let's see, so while we're waiting, I'll just make an announcement from Quasi. Quasi just opened registration for the 2016 Watershed Science Masterclass, which is a short course targeted towards graduate students and postdocs. And it's a week-long course that's going to take place at Biosphere 2 in Tucson, Arizona. And it's going to be an immersion into watershed processes such as theory, experimental design, and modeling. So if that's something that you would be interested in, I'm going to put the registration link into the chat box and you can check it out.
And Steve, in your follow-up comment, yes, I've read that paper. It's been well circulated through the drought community, and I agree with you. It is a very, very good paper on this aggregate drought index, and yes. So it looks like we do have someone still typing a question in the chat box. Again, any questions you may have, I'll be glad to spend some time answering them.
Hey Brian, I'll cheat and use the phone.
Okay.
A quick question about automation. Do you ever see it going to the automated side where you just do it sort of a manual check really quick, or is it you're always going to be doing this hard full-on authorship? Is there a push for that down the road?
That's not a slide I didn't show, which I should have. In the very beginning of the drought monitor work, the Climate Prediction Center put together what we call our objective blends. And these are, there's a short-term blend and a long-term blend based on those different time criteria. And what they are, and again, they're still based off of climate division data yet today, but I'll talk about that a little bit more too, is they were more of a composite drought index where the inputs were identified and then they were weighted, and then you could run the process and get a short-term drought map and a long-term drought map based off of these indicators. When this was developed, there was a lot of trial and error, and I think it's a good research project that someone could look at. But with the climate division-based data, we do have these available, and they are operational, and the Climate Prediction Center does produce them. They can be a fairly good first guess. So if I come into the map and I look at these blended indicators, but even with those, the indicators themselves had to have been subjectively chosen. The weights were subjectively chosen. And the idea of something that's completely automated, the key piece of information that we miss is that local feedback, that information on impacts. It's something that you just can't replicate. And so I think the idea of having maybe this first guess help us out is definitely something, and we are working here at the National Drought Mitigation Center to take those climate division-based objective blends, and we are building them into a gridded base, and so a little bit finer resolution. And also the idea is we want to replicate what's been done since 2000, but we also want to change it where we can put new indicators in there as well as different weighting schemes. And this is something, again, I think it turns into more of a research topic, that what is the most ideal blend of indicators, and then what's the most ideal weighting scheme of those indicators. But it is something that, as an author, I think it would be a good first guess, and I think as we get these gridded objective blends produced here in the next year at our shop, it should start shedding some more light on this as well. So do I ever see it going completely automated like that? No. And that's another reason why we've never built an archive up prior to the beginning in 2000, is just that impact information and that local feedback is very hard to replicate. We could take all the indicators and classify them as D1, D2, D3, D4, but then again we would have to determine a weighting scheme, which indicators to use, seasonality of some of the indicators, so it does become complex.
Yeah, really quickly.
Yeah, in a hurry.
Thanks.
So there's a question here by Yulong. Recently we found that length of data records has significant impact on drought intensity, in particular D4. When we want to update the NLDAS drought monitor for 28 years to 36 years, any methods or thoughts to select optimal, reasonable climatology to calculate the percentile? Yeah, one of the tools that we have developed here at the National Drought Mitigation Center is this Drought Risk Atlas. And within the Drought Risk Atlas, we found the best long-term, most complete cooperative weather stations in the country, and we calculated the drought histories as far back as possible, and we had this same question: what is the most ideal length of time? And working with, I don't know if any of you remember who Ned Gutman is. He's in the literature quite a bit, but he was really good with answering this question, and he worked with us on the Drought Atlas. And the discussions I had with Ned is ideally you would like to have a minimum of 40 years of data. Ideally, you would have 50 or 60 years of data to get a proper climatology. And in the Drought Atlas, we went back and forth, and we decided that 40 years was going to be our minimum standard, our minimum threshold. But with anything related to climate, the longer your period of record is, the more opportunity you have for having those extreme events, which drought and flood are. They're the tail ends on either side of the distribution. And so ideally, 50 or 60 years of data is going to be the best, especially when you're talking D4, which is a 1 in 50 year or more type of event. That the longer that period of record is, the better chance of properly identifying exactly what D4 is becomes available. And Steve, I see your comment too about computer science colleagues trying to do this machine learning and map blending. We were approached by a PhD student here at the University of Nebraska who was doing his dissertation on that topic, and he was looking at drought. And I know he graduated, but I never did see the final results of his dissertation. But you're right, there is a lot of the computer science folks are trying to dig into this and see what can be done. I see you Long is typing. Any other questions?
All right, looks like you Long just submitted a question here.
Yeah, and with the WMO suggestion, many times with the groups that WMO is working with, they are in data poor regions, and so even coming up with a 30-year climatology, Yulong, is difficult for some of them. That's why 30 years is definitely the minimum threshold, even though for indicators such as the SPI, you can calculate it with as few as years of 20 years of data. But, with anything climate related, the longer the period of record is, the better results you're going to get from it. So Steve is typing a question. All right, thank you for the comments. And so just to let everyone know too, we are planning the next forum for the spring of 2016. It looks like it's going to be either in late March or early April in Dallas-Fort Worth in conjunction with the southern region of the National Weather Service. So there should be some announcements coming out on the webpage of the U.S. Drought Monitor as well as the National Drought Mitigation Center as those plans get finalized.
All right, well, thank you, Brian. If there are no more questions, we'll go ahead and end the meeting for the afternoon. But the Cyberseminar will be posted on the Quasi website. And we hope that you will join us next week for the last presentation in this fall Cyberseminar series when Narendra Das from NASA's Jet Propulsion Laboratory will give a talk. So thank you, Brian, and thank you, Todd, and thank you all for participating in the webinar. We hope to see you next week.
All right, thank you, everyone.
Yeah, thanks. And thank you, Emily. Take care.